This video explains statistical quality controls, tools and techniques using Microsoft Excel. And we will discuss topics such as run charts and control charts, Pareto analysis, fishbone diagram, acceptance sampling, and some other topics. We will start with run charts and control charts. Now, this is the data that's about glucose level of some patient. In first column we have number of weeks, in second column we have glucose level. So the first thing we do is making a run chart, and for that I select data and press Ctrl Q, and after that in charts click line chart, and this gives this run chart. And let's add here some axis is already there. We will also add axis title, chart title, legends. We will also add that, and let me add here titles for X and Y axis. We can also trim Y axis to eliminate these blank spaces, and for this purpose I will click on format axis, where minimum value we can set it to 30 and maximum value we can set it to 230. After trimming y-axis we get this one, and this is our run chart. Now the next step is making a control chart. A control chart will be similar to the run chart, with the only difference that we will add here an upper control limit and here a lower control limit, and in the center there will be a line that's called median line, that will be center line. Let's add these three lines, and for that what we need is first we will take average, and then next step is calculating range. Range will be the difference of these individual values with the average. So we say, and we'll take absolute value, that's a difference of this value minus average, and I will lock it because in the next step we have to drag it. Also take average of range. To calculate lower control limit we will use this formula, average, and we will lock it, F4 minus 2.66. 2.66 is a statistically derived number that corresponds to 3 standard deviation from the center line, and that will be multiplied by average of range, and again I will lock it because we will be dragging it in the next step. So our lower control limit turns out to be 82.67, and upper control limit will be exactly the same thing, with the only difference that the negative sign will be replaced with a positive sign. So upper control limit will be is equal to average, F4 locked, plus 2.66 multiplied by average of range, that's also locked, okay, and the last thing will be median value, that's median, and median of this one, and I will lock it because there is only one median value, so I will lock this whole column, that's 131.5. Okay, so far we have like this data, that's a glucose, and then we take its average at the bottom, and then we take range, that's a difference of average and these individual values, and then lower control limit, the formula for which is average minus 2.66 multiplied by range, and upper control limit is average plus 2.66 multiplied by average of range. Okay, to make a control chart we have two options. One option is to convert this run chart into a control chart, and the other is to make a separate control chart. If we want to convert this run chart into a control chart, then we click on this one and then you click on select data, and in select data then you can edit this one. You can add here upper control limit and then lower control limit and then median. But I would like to make a separate chart for control chart, and for that we select this whole data, control Q, and then go to run chart. So here's our run chart, and in this run chart there are some values that are not of our interest. So for example, this one, if I look this one, this orange one, legends show that this is range. We don't need this, so I will delete this one. Now in the next step I will eliminate these spaces, and I will trim this y-axis, format axis, and maybe we can start with 50. Minimum value could be 50, and for this one I'll go for more options, and value from cell, and I want values to appear from this one, that's number of week 1 2 3, not glucose level. So I will select this column, that's number of week, click OK. And when you look at this chart, it shows that this is our center line, that's called median line. This is upper control limit, this is lower control limit, and this is our data line. Now it shows that in general data points are oscillating around median line, and except at one point, that's point number 8, where it seems to be out of control. And if we look at 8, that's 216, that's really an abnormal value, much higher than the other one, also much higher than the average value. So control charts give us an idea that is the process in control or out of control, or is there a tendency. Our next topic is Pareto analysis. Pareto analysis is used when we want to prioritize problems. So for example, those problems that occur most frequently, we want to address them first, and those problems that occur very rarely, we want to put them on the back burner. The starting point here is that for example, this is our data, and it has these problems, and this is count or frequency. The first step is that we will sort them, custom sort, and sort by count, that's column B, and largest to smallest, this one. Now there are two parts. In one part we can make a chart, or let's first go with more informative numbers. We will calculate percent, and that will be, we also need to calculate total, that's sum, and percentage will be this one divided by total locked 20%. And then in the next step we will find out cumulative, and cumulative will be the first cell is equal to just this one, and then the next one will be this value plus the top value. So that's 20%. 20 plus 19 is 39, and then 39 plus 12, it should be 51, 50, and then the total should be 100%. Now let's also make a plateau chart. Just select this data, press Ctrl Q, charts, more charts, and plateau chart should be here at the bottom. Okay, so that's a plateau chart, and this plateau chart it shows that what are the problems that occur most frequently, and we can see here that sales after service has the highest frequency, followed by documents, and then reliability, and then damaged product. And when we look at these numbers, it shows that that's a cumulative frequency, and if we could identify roughly 80%, so these are like 80%. So when you look at cumulative frequency problem, this is 78%, roughly 80%. We can also provide here conditional formatting, whereby we can say that those cells that contain up to 80%, we want to make them green. So that's all about a plateau chart. And it also means that the interpretation is that management should focus on these problems on a priority basis. The next topic is fishbone diagram, also called as Ishikawa diagram. Fishbone diagram is used for identification of root cause of a problem. So this is a fishbone diagram, and the model or framework that is used for identifying problem is either called as 4M. 4M is one model, which means 1M is man, material, method, and machine. And you can also add some other elements like environment or miscellaneous, because there will always some problem that may not belong to any of these four categories. So you can always add here a miscellaneous category. And the other one is PIPS, that's process, information, people, and system. Most of the time problems, they usually fall in these categories. So what happens is that in making a fishbone diagram, it's usually a consensus based decision making, whereby we take input from other people and we try to identify the root cause of the problem that's usually unknown. So for example, why a process is not as much efficient as it should be, because there might be some problem related to man. And what could be those problems? They could be related to fatigue, they could be related to lack of training, they could be related to negligence, etc. Then there can be some problem related to material. For example, the material is not of the required quality, or there is some deviation, or material was changed. There could be these problems, they could relate to machine, or they could be about method. Similarly, if we use the other framework, that's PIPS, then process could be one way that can contribute to problems. So if we use here process, then we will find out all those factors that belong to process, and we will try to go in depth as much as possible to find the root cause of the problem. Then next thing is information, and that information, it could be information about process or management related information, etc. Then people, we discussed it earlier in man category. And then system. So, and in system category, it could be about organizational system, it could be about process, and it could be about the monkey, it could be about apparatus. So as you know that monkey and apparatus, that they cannot be isolated from each other. Monkey represents the human side, and apparatus represents the technical side of the organization. So in system there could be factors that could be about humans, or it could be about technical system, the overall system, and it could be about how these social and technical sides, they are intertwined together. The process of making fishbone diagram is relatively straightforward and easy in Microsoft Excel. Most of the time we'll be using these shapes. The validation, and then in data validation I want these four options to appear here in the form of a drop down list from where I can choose. So for that purpose I will choose list, and source I'll be using these four, and I will lock them F4 and click OK. So for example, let's say if initiative A, the person who was responsible for that, if we say they have already completed that, so we can say completed. The second one we can say it is started, and the third one, let's say we say in process, and the fourth one we can say not yet started. And one last thing that we can do is that regarding aesthetics, we can make it a little bit more beautiful, and for that purpose I will go to conditional formatting. In conditional formatting we say new rules, and format that cells contain equal to, and the first one, let's say completed, and I want to appear as green. And for the started one, when initiative 2 is completed, we can just click on completed. Our next topic is acceptance sampling. In acceptance sampling, a quality inspector takes some samples from an incoming lot and finds out defects and compares them against a predetermined number. If the number of defects in that lot exceeds the predetermined number or a critical number, then the lot is rejected, sent back to the supplier, or maybe it will be subjected to 100% inspection. Acceptance sampling builds upon binomial probability. Now pause the video for a minute to recall the prerequisites for binomial probability. Acceptance sampling also meets the conditions for binomial probability, and therefore we use it to build a sampling plan for acceptance sampling. Now consider this example. Here for instance we have C, and that's the number of allowed defects, and this is the probability of finding defects, and the total number of samples is 20. The formula for binomial probability is binom dot distribution, and then the first is value of C, that's F4, and then number of trials, that's 20, and then probability, that's 5%, and then do we want cumulative probability or only probability of 0? So right now we only want probability of 0, so I will write here false, which means not cumulative. We want to use this value of 0 in this row, which means we want to use this value when probability is 10%, 15, and like that. So we will convert it, or we will lock it in such a way that it is locked for rows, and for that purpose I will lock it, or I will press F4 key a number of times, let's say If I press it one time, then it's totally locked. If I press it second time, then dollar sign appears in the middle, which means it's locked for the column. That's not what I want. Then I will press it third time, then dollar sign comes up front, which means it's locked for the key, for the row. That's what I want. In other words, what I want is that I want this zero, the value of zero, to be relevant or to be applied to this whole row. Uh, for for the column, I do not want to lock it because I want other values to be used in this column. Now the next thing is 20. 20 is a constant. It doesn't need to be locked because it's not the number of a cell, it's a value. The next thing is this one, that's a probability, that's 5%. Now this 5%, we want this probability value to be applicable to all these cells in this column. So in other words, we want to lock it for the column, and for that, if I press F4 key one time, it's totally locked, and if I press it two times, then dollar sign appears in the middle, and it means this is locked for the column but not for the rows, and that's what we want. And then we can drag it. So here we go. This acceptance sampling plan gives us a probability of individual values of C. So this is 36% only when the value of 0, and 38% for 1, and for 2 it's 19%. But in real life we are interested in the probability of up to 2. For instance, let's say we are not interested in the probability of exactly 2 outcome, but we are interested in the probability of up to 2 outcome, which means including a probability of 0, 1 and 2. And in that case we will use cumulative function. And for cumulative function we will use exactly the same formula, with the only difference that this false will be changed with true. For cumulative probability I use exactly the same formula, with the only difference that I have placed here true instead of false, but the rest remains the same. That's the value of C, N, probability, and then cumulative, and then that gives us 92% probability, which means that's a cumulative probability. We are using here the value of C2, which means it includes 0, 1 and 2. So in other words, it should be exactly the same thing as this one, 0, 1 and 2. We can double check it, is equal to sum of probability of 0, 1 and 2. Yeah, that's right, it gives us 92%. Now the interpretation of this acceptance sampling plan is that 92% is the probability of finding 2 or fewer defects in that lot. And because 2 is the number to which you have already agreed, because it's a part of your sampling plan where you allowed number of allowed defects is 2. So we can say that the probability that this lot will be accepted is 92%.